Okay. All right, we're going to talk about series. And we talked about sequences. And now we're going to talk about series. So we know what a sequence is. It's just a series of objects, or I'm sorry, it's just a sequence of objects or numbers and things like that. Just a list, right? So 1, 2, 3, 4, 5. That's a sequence. Okay, well, a series is just if I take a sequence and I just add them up. So this is the corresponding series 1 plus 2 plus 3 plus 4 plus 5, right? That's it. So remember that we have some notation for the terms in a sequence. We have the first term is A1, second is A2, the nth term, right? The nth term is A sub n, right? And so we have to remember our notation. So we have a special notation to talk about the addition part, the summing, right? The addition. And we use the capital Greek letter sigma. It's an S, right? Sigma means, think of the S for sum. Sigma is we're going to sum up all of these values. So if we want to add the first 5 terms, 1, 2, 3, 4, 5, what we have to do is this. All right, I'm going to start with 1, and I'm going to go to 5. That's location, okay? Term 1, term 2, term 3, term 4, term 5, okay? And I want to start there. My equation is on this side. So for this equation, it says, okay, let k be 1. So start there, 1. Then use sigma, that means plus. Now go up to the next one, that's 2. Okay, plug 2 in here. Use the sigma, that's plus. Now go to 3. Now go to 4. Stop at 5. And that's what that notation is meaning, okay? So sigma is the notation for sum. This is the formula for the nth term, whatever it may be. This is called the index, okay? It's like a counter. Some books use I. And this is the term that we start with. So plugging in values. And we're going to stop here, okay? It says, notice that we're using K instead of N. The importance of that will come later, but just know that it's a little bit of a different notation here in the notes. So for the sequence whose nth term, the equation is simply given by n, we're going to, again, here's our equation. We start at 1. Plug in 1, I get 1. Plus, plug in 2, I get 2. Let k be 2, let k be 3, 4, and 5. Stop at 5. Add them all up, and you get 15. Let's do another one so you can kind of, that way we'll have a little bit more notation to get used to. Here it says we're going to start at plugging in 3 and we're going to stop at 6. So I'm going to start here. So K is going to be plug in 3. So 2 times 3 plus sign because it's sigma. Now I'm going to go up to 4. Plug in 4. 2 and a 4. Right? You see it here? K is 4. Now we're going to go to 5. Plug in, K is 5. Okay? Then we're going to go up to 6. And we're going to stop at 6. Okay? So writing this out, add them all up, do the math, and we get 36. Not too bad. Not too bad. Now we're going to do one that's just a little bit more complicated. Okay? Not terrible, though. Where do we start? We start at 0. So I've got 5 plus 4 times 0. Sigma means plus, so go to the next one. Now I'm going to let it be 1. 5 plus 4 times 1 plus. Now I'm going to let it be 2. I've got 5. Nope, that's okay. Sorry. 5 plus 4 times 2 plus. Now I'm going to wait. No, I'm going to stop. Why? Because I was supposed to stop at 2. Okay? So what do I have here? I've got 5 plus 0, so that's 5, plus. I've got 5 plus 4 times 1, which is 4. So I've got a 9 plus, I've got a 5 plus 4 times 2 is 8. So I've got 5 plus 8, that's 13. So add them all up and we get 27. Not too bad. Here's where it can get a little weird. Some basic notation for different types of sequences or series. The evens, all the even numbers, okay? If it's 2 to any number multiplied by 2 is even. So it makes sense that I have a 2 times whatever number I am plugging in. And if I want all the evens, the first even number is 2. So how do I get 2 times what will give me 2? Oh yeah, okay, 2 times 1 will get me 2. So I'm going to start at 1. And where do I want to go to? All of the evens. So infinite. ... That's an infinite series. Remember we talked about that last time. Again, notice that infinity. It means it goes on and on and on forever. What if instead I wanted to start at 0, not the 2? This one started at 2. What if I want to start at 0? Well, all you're going to have to do is change the bottom, right? How do I get this? 2 times what gets me 0? Oh, well, 2 times 0 gets me 0. So I'll start at 0. Let's talk about the odds. If I take any even number and I add 1, that gets me an odd. If I take any even number and subtract 1, that gets me an odd. Depending on what it is you want to do, plus or minus, is going to dictate where you start. For example, let's do the plus one. 2 times a number plus 1. Well, I want the first odd number is a 1. So let's think about this. I want a 1. 2 times 0 will knock that off. That'll get me a 1. So that will work. That will work. Let k be 0 in this case. What if I want to talk about subtraction? 2 times something minus 1. 2 times 1 will get me 2. So 2 minus 1 will get me 1. So that means I'm going to let KB start at 1. So that's why these get you the same sequence. The equation, notice the notation, the equations are different. And when the equations are different, you have to think about the starting values, right? Where are you starting? So always check the first few terms to make sure that your equations are working. Let's take a look and see if we can actually write out some sigma notation, okay? All right, let's look at this. I've got a 1, a -3, a 5, a -7, a 9, a negative. All right, first thing we notice, alternating signs. Alternating signs. All right, so let's go ahead and just start our sigma notation. I don't know what it's going to be, but we're going to work on it. The first thing I notice is it's alternating signs. So I'm going to have a -1 to the k. -1 to the first power gets me a -1. -1 to the second power means -1 times -1. Oh, that gets me a positive. -1 to the third, odd. -1 to the fourth, positive. So this is alternating signs. That's the piece you need to have. Oopsie. This is the piece you need to have when you have alternating signs. Next, let's take a look at what are the actual numbers. I have a 1, I have a 3, I have a 5, I have a 7, I have a 9. Those are all odd numbers. Those are all odd numbers. So basically, go up here and pick your favorite. Which one do you like? Do you want to do the 2k plus 1? Well, if you want to do 2k plus 1, remember that was one of the ways to get an odd, we have to start at 0. So let's see if this works. Hang on. -1 to the 0 power. Anything to the 0 power is 1. 2 times a 0 is 0 plus 1. So 1 times 1 gets me 1. That works. So, and goes on forever. That's why we have the infinity. Let's take a look at this one. Let's see. Write the sigma notation 4. Again, we have negative, positive, negative, positive, negative, positive. So, alternating signs. alternating signs. Automatically, I know I'm going to have a negative 1 to the k power. I don't know where I'm starting with, but I at least know that, okay? Next, let's take a look at the terms, the numbers. I've got a 1, a 4, a 9, a 16, a 25. These are all squared. This is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So 1 squared here gets me this one. 2 squared here, let's check it. If k is 1, negative 1 to the first power is a negative. If I plug in 1 squared, that's a 1. 1 times a negative 1, that gets me the negative 1. Let's try 2. When k is 2, negative 1 squared is a positive 1. So a positive 1. And then I have 2 times, oopsie, I have 2 squared, that's 4, positive 4. Okay, good, that works. And then we have this, which means I need the infinity. Goes on forever. Couple of helpful rules. When you have the summation of two terms being added, what's really nice is you get to break these apart. It's really lovely. Same thing with subtraction. You get to break those apart. And the one that's awesome is that if you have some number, some constant on the outside here, so like say we had 2k squared, like this, I get to pull the 2 out, which just makes the math so much easier. And the reason is because every single term is going to have 2 times. Well, just pull the 2 out and you have the same thing. Yes, you can do this on graphing calculators. It's the sum of a sequence. You go to your second stat, you go to the list option, you arrow over to math. You want to go down to the sum because you're summing a sequence, okay? Then you go second stat, go to the list option, OPS, go down to sequence, and then you put in all the values that you did when we were talking about sequences. Not too bad. Let me see if I can, let's see. All right, so here's my list. So second stat gets me my list option. I want to go over to math, and I want to go to, sum. And then I want to go, again, second list. This time I want to go down to, OPS. I want to go to sequence. The sequence is telling you need the expression, you need the variable, the begin, the end, and the increment. All right, what is the expression? What was our expression? We have 6k minus 4. Okay, so I have 6. You don't have k's, you have x, tau, theta, n. We're going to use that button. And it was, what was it, minus 4? Minus 4. Okay, comma. Now what do you need? The variable. The variable's x. Comma. Where does this one start? This one says k starts from 1 goes to 3. So start at 1, comma, end at 3, comma, increment. I want every single term. So 1, close it up and hit enter, and it'll give it for you.